moons and comets and that kind of stuff. We'll not get through all of the slides I have, but we'll get through some. This here is a picture looking at Jupiter in radio waves, not what we normally see Jupiter as. Now, when I looked at this more carefully, I saw that's not showing the rings of Jupiter, that's showing the magnetosphere. That is, it's illustrating where the magnetic field is because you have particles that are trapped in that magnetic field. Here's looking at Neptune. Neptune has this blue spot, which, if I remember right, that it's a cyclonic storm, just like the Great Red Spot. But I think that it is gone now, that storm has ended. It's, I think that was an example of one that they thought was maybe last a very long time, like the one on Jupiter, but it's ended. Moons. Shifting to moons. Moons of Jupiter. Jupiter has, I can't read anymore because I wrote them on my hand 2 days ago for class. But Jupiter has, I believe, 67 known moons. It's a lot of moons. Most of those moons are little tiny guys or girls. They're little tiny things that are orbiting Jupiter. But there are 4 that are major. And so those are the ones that Galileo saw, and they're called the Galilean moons after Galileo. And so this is showing pictures of them to give you the relative sizes. You have Ganymede, which is the biggest one here, I believe. And then you have Callisto. And, whoops, that's Io. Io and Europa. Now, Michael Jackson and Disney together did us no favors because for a long time at Disneyland at least, there was Captain EO, which is not pronouncing Io correctly. I think they use EO instead of Io, but you think that it must have something to do with this. No. So those are the 4 Galilean moons, and those moons are of significant size. So here we can see relative sizes of Earth and the Earth's moon, Jupiter's moons. Look at Jupiter's moons. Ganymede, very, very big. Ganymede is the largest moon in the solar system, and it is larger than Mercury. So, yeah. What makes it a moon instead of a planet if it's larger than Mercury? Somebody should check me and make sure I'm right on that.
It doesn't orbit around us.
Yeah, it hasn't cleared its space. It's orbiting something else. It's secondary to much bigger Jupiter. So Jupiter is the master. It's the subservient one, the one that is doing what Jupiter tells it to do. Now, there's some really cool things I don't have any slides about for these moons here. Orbital resonance. Now, we've seen some examples of resonance. First, there's our moon is tidally locked, so its rotation and its orbit are in a resonance, a 1-to-1 ratio. As it does 1 orbit for 1 rotation, which means that we always see the same side. Mercury's orbit about the sun has a much more interesting resonance. It has that 3-to-2 ratio, that it does 3 rotations in the time it takes to do 2 orbits, and thus it has 1 day per 2 years on Mercury. Very weird. Well, these here, these Galilean moons have a 1-to-2 to 4. I think it's 1-to-4. And then this one here has not reached resonance yet. But you have a resonance that's set up between the 3 inner ones, and the 4th one is somewhere in the ballpark, but not there. So that every 2 times Io orbits, Europa will do 1. Every 2 times Europa orbits, Ganymede will do 1. And so these are resonances that are set up to produce a lower energy system. So it's really cool, I think. You could think whatever you want, I suppose. But you should think like I do. That's silly talk. You're supposed to laugh like Alex did. Thank you. Other major moons in the solar system, besides the 4 Galilean moons and the Earth's moon, we have one major moon for Saturn, Titan, and one major moon for Neptune, Triton. The other ones are smaller. Charon here is a major moon as well. I think generally they say there's 9 major moons in total. Let's see how many did I identify. 1, 2, 3, 5, 6, 7, 8. So there must be one more here that I did not identify that's considered a major moon. Obviously, it's a smaller one. Maybe Rhea, I don't know. So major moons, then lesser moons. What would make a moon major? Yeah, size. Just bigger ones are going to be the ones that are major. The smaller ones, you have lots and lots of small ones. For instance, we have some pictures coming up of Mars's 2 moons. Remember, you need to know things about the planets for the test, right? You're going to need to know the planets in order from the closest one to the farthest one. And then you're going to have to do some comparison of a single aspect. So that single aspect could be about the atmosphere, how does the atmosphere compare on the different planets? Could be on the moons, how many moons do they have? So on the moons, let's just go over that number. How many moons does Mercury have?
0.
How many moons does Venus have?
0.
How many moons does the Earth have?
1.
1. How many, one natural body we consider it? How many does Mars have?
2.
2. How many does Jupiter have?
67.
67. How many does Venus have?
Less than that.
Wait, Venus?
Not
No,
Venus, I
Saturn.
meant to say Saturn.
Oh,
Yes.
yeah, that's what I thought.
I did for Saturn.
Saturn has 60.
62, I believe.
Okay.
So almost as many as Jupiter.
Yeah.
And then the last 2 have like 17 and 14, something like that. You don't need to know the exact numbers for the outer ones. Just lots, and many. Yeah, so 1, 2, lots, many. How's that sound?
1, 2, lots.
Yes.
So this test is going to be different than the last one. There's going to be more short answer for the comparisons and things, or
It will be pretty much like the last one. You'll have true and false, multiple choice, and then one question. Instead of one question being on the scientific method, it's going to be list the planets in order, and then I will tell you on the test what aspect you're going to have to compare them.
So we have to
Okay, what do you mean?
So what are the...
So things it could be, like I said, it could be the atmosphere. Like, Mercury has no permanent atmosphere. Atmospheric pressure on Mercury is, I forgot how small it is. You can look on the solution for the last one. We're going to put it on there.
Are we gonna go over that in the review, those specific atmospheres and kind of stuff like that, or do we need to look that up on our own, in the book and
It
stuff?
should be
Well,
it's in our homework.
Yeah, it's in your homework.
Okay.
These are just examples of different things I could choose from. So, and then, you have 90 times the atmospheric pressure on Venus as we have on Earth. Earth has Earth's atmospheric pressure is what we have it. And then it's 0.6% of Earth's atmospheric pressure on Mars. And then the others, they're gas giants. They just have these really thick atmospheres. Then you could be asked about composition of the atmosphere. So, again, Mercury, virtually nothing, but it's dominated by hydrogen, whatever there is there. And then, what's the major gas on Venus? It's what?
CO2.
Okay, CO2. I don't know what I heard. Okay, carbon dioxide. On Earth, what's the dominant gas?
Nitrogen.
Nitrogen. What's the secondary gas on Earth?
Oxygen.
Oxygen. What is the ratio of those?
20, oh wait, 70-20 around there.
I know the one
Closer to 80-20.
80.
Our textbook says 78-21.
There we go. Yeah.
The official homework key said 80-20. It's like 96.7% CO2 on Venus, like 95.5% CO2 on Mars. And so primarily CO2 there. What about when you get out to the Jovian planets? Primarily hydrogen. Yeah, there's trace amounts of other things. Where are the ice giants? Uranus and Neptune. Where are the gas giants? So you might be having to name those. Lots of different things. Which ones have active tectonic plates? We do.
Yeah.
Mars used to, but apparently not anymore. I believe Venus still does. Right, so those are the kinds of things we need to know. Okay, coming back to this, talking about the moons.
You're like,
Dark to the heart, is that what you're saying?
I'm just saying.
Oh, crash and burn. Here, we're going to look at the Galilean moons. So, Callisto, the farthest out of the Galilean moons. It's the farthest away from Jupiter. It is an ice ball. Now, Jupiter is not the sun. It's not giving off large amounts of radiation. But the closer you are, the bigger the tidal action. And so as we'll see, Io being really close to Jupiter has significant tidal action. So Io is constantly getting worked by Jupiter. And as a result, it's full of volcanoes. Because all of that being compressed and stretched is causing friction and heat. So here we have Callisto. It has a hard ice surface, as far as we can tell. Shows heavily cratered surface. That means that the surface is old. If it was young, the craters, if it was young, you wouldn't have any craters because it would only be recent times craters that would be there. So it's considered an old surface, very hard, probably thick ice. You go to Ganymede. Ganymede is similar, but a younger surface. And you have evidence of some plate tectonics action with its ice crust. Then you get to Europa. Europa, clear signs of motion of plates. Europa is considered really important. Why really important? Because Europa, and also Ganymede, they believe that it has a liquid ocean, a water ocean, and that it probably has, energy still coming out, so there's sources of heat in that ocean. And what we've learned about life on Earth is that we have organisms that can live in the deep ocean vents, where there's energy supplied by the vents of hot material, not from light. And so scientists believe if there is any reasonable place for life to have spontaneously formed outside of Earth, Europa in the oceans there is a real high likelihood. And so scientists are really excited to, at some point, send some kind of probe to go through the surface, go down there, and try to find signs of life on Europa. And so to that end, when we have satellites that go to Jupiter, they make sure that they don't have any interaction between the satellite and Europa. They don't want the satellite to accidentally crash into Europa, for instance. They don't just send a probe down there willy-nilly. They're waiting until they have the right probe, because they don't want to have a probe come from Earth, land there, and then they come back 20 years later and they find a colony of stuff that came from Earth to Europa. Question, Leslie?
so they still haven't sent anything into Europa yet?
They've orbited around it, but no. I mean, they haven't actually landed on any of these Galilean moons. But Europa they're really concerned about, because they think that would be our best chance of finding life that formed somewhere away from Earth. Then Io, which is totally cool. Io, it looks like a rotten pizza, right?
Yeah.
What is it Carl Sagan called it? Looks as if it desperately needs a shot of penicillin. That's because it has all of those volcanoes that are spewing sulfur. I mean, this is your hellfire and brimstone type environment right here. Right? That's what the brimstone is. So it would be a very inhospitable place. I've got some cool pictures here. You can see volcano on the limb. The limb is when you're looking at the edge of the planet. And then another one where you see a face-down view of a volcano.
Wait, that's the mountain, or is that like a gas?
That's gas. That's what's being expelled. And that's being driven by the gravitational working of, yeah.
So when we people are looking for other places that could be possibility, for life to be sustained or whatever, is it for the purpose of just education? Is it because they're worried about overpopulation on Earth, or what's going on? Why is that?
Well, basically anything short of talking about Mars is going to be trying to just learn more about life and looking for that magic bullet for, yes, here's how life could have formed.
Oh, so that's a whole
Yeah. With Mars, people could be worried about overpopulation and going to another planet. But nobody's going to talk about going to Jupiter, and it's really unlikely anybody would talk about going to a moon of Jupiter until millions of years down the line, billions of years down the line when the sun is dying. When the sun is dying, it's been suggested that maybe humanity can move out to, was it Titan? It's either Titan or Triton. Maybe humanity can move out there when the sun becomes a red giant and incinerates the Earth. But for now, it'd be way too cold out there. So yeah, they're generally not talking about for us to go. Okay, here's a nice view of the surface of Io, and you can see some active lava over there on the left. So a lot of geological activity on Io. Io is not an ice ball in any way, shape, or form. It's worked so much by gravity. Here's a comparison of the icy surfaces of the three outer planets of Jupiter, or moons of Jupiter. And you can see that the craters vary. This is a very old surface, lots of craters that show lots of aging. A younger surface where you see a lot of cracks and stuff. Here's something that's much younger that's frozen over. Then this surface, you hardly see any craters. It's just plate tectonics action that gives you the features you see. So you can see differences in what the surfaces look like to tell you about the ages. Now, Saturn's moon Titan is one of those interesting places where you might have a rain, constant rain, that would be a caustic rain, but you have clouds of methane or ethane. I mean, I suppose if it's ethane, that's what people used to drink. Methane would make you blind if you were to drink it, among other things. So it's not a good thing. If you had oxygen, you could readily burn that atmosphere. But it's much colder than Earth. Temperatures you see there are the highest temperature, 160 some. Certainly not a place where we could live today. Here's the surface of Titan. Amazing. You look at this and you're like, that looks kind of like a desert, right? Yeah. Boulders are made of water ice. Not quite the same as what we think of as deserts here. Now, if you want to be all technical, what is it? Antarctica is a desert? But, so desert doesn't mean hot place. But that is not, it looks like a hot, barren desert like you're in Arizona. Not so much. But to me, it's very interesting just to note what the surfaces of these things look like in, a novel situation where you have things that on Earth would look one way, look very different there. Yes?
What took this?
It says here, the descent camera. Okay, it doesn't say what the descent camera was from. Yeah, it doesn't say what the descent camera was on. But a descent camera, something that came down as a probe. And then Neptune's moon Triton has large ice caps. Just looking at these moons, looking at the surface, would you call this a young or an old surface? Okay. Alwan said young. if you look above this line, definitely looks young. Down below, it looks like it might be a bit older. So, what happened? Why are they looking different? Well, the answer is most likely an impact. An impact that caused the part that's young to resurface, and then the older part wasn't. I put this picture in. Normally I'd skip over it, but I just wanted you to appreciate what it used to be an astronomer. This here is the slides that Clyde Tombaugh was looking at when he discovered Pluto. Now remember, Pluto was predicted, and then they looked for it. And so he was looking at sky plates of pictures that were taken 6 days apart and looking for anything that changed. Because remember, planets are wanderers. So the planets would be things that are changing. Also, comets would be things that are changing. So what they did was they used what's called a flip camera, where they would flip back and forth between two pictures. I don't know why it's called a camera. It's a viewer, right? Maybe it is a flip viewer, and I'm misremembering wrong. But they flip back and forth between two pictures and look for anything that's changing. So you're using the brain's ability to note changes and looking for a change when you flip back and forth. And what he saw was, and I'm going to circle it here, it's easier to see on my thing than it is for you to see. He saw this thing that moved. Now, if you do a comparison, note these, changing my pen color to yellow. Those stars, the thing that's pointed out in the right-hand picture is to the right of those stars. Here's those same stars. It's to the left of that. So it moved across those stars. That's a pretty clear difference in motion. And so he noticed that and said, there's an object that's moving. It's a wanderer, a planet. That's how it was discovered. Aren't you glad that that's not your job to sit there and just flip pictures back and forth and look for did anything change? Yes or no? Go to the next step. Anything change? Yes or no? That would be really tedious. Nowadays, we would use computers to analyze it. Be much easier, wouldn't it? So Pluto, why is Pluto not a planet? Well, it comes down to size in the end. It comes down to size. It's small. Here's the size of Pluto compared to Earth. And this here is the size of its moon. Notice the spelling of the moon. Okay, got to change colors if you want to read that. That's Charon. I read a book, The Ring of Charon, and of course I was an ignorant graduate student. I read it as Sharon. But Charon is apparently the boatman that guides you over the river Styx to get to hell.
Yeah, C-H-A-R-O-N.
Yes.
C-H-I-R-O-N.
C-H-I-R-O-N is a centaur. We have a picture, or we have a thing on Chiron coming up. So Pluto is small. Do you remember the standards that were set for what makes it a planet or not a planet to separate them? Okay, two things. That's the second one. Well, actually, a third one, if you want to be all technical, it has to orbit the sun. It has to have enough mass for gravity to pull it into a roughly spherical shape, and then it has to clear up its own space. And that clear its own space is the important one that Pluto fails. And fails miserably. Its moon there, Charon, is like 1/3 its size, or mass. So it's 1/4 the total mass system, if I remember right, is Charon. Some people propose that it be a double planet. Basic reason scientists ruled it out as a planet is not because it didn't clear its own space. That was just the rule they made so that it would be ruled out. It's because it doesn't fit in with the other planets. All the other planets are big rocks, and Pluto isn't a big rock. That's the real driving force. There are lots of objects like Pluto. We call them dwarf planets. There are 5 officially accepted ones, and there are others that eventually will be accepted. So Pluto's small. We've learned a lot about Pluto from the New Horizons spacecraft. The New Horizons spacecraft flew by Pluto, wow, I think it was 2015.
Yeah.
It seemed like it was just a few years ago. I was in the process of reviewing this textbook when it flew by, so I thought that was pretty exciting. I'm glad to see that they included stuff on it in the textbook. So one of the things you note from the flyby is the atmosphere on Pluto. The atmosphere on Pluto is less than was actually previously thought, which means that Pluto is actually larger than they had previously thought, so that while Pluto is still smaller than Eris, it's closer in size than they had thought. But it definitely has some atmosphere. How would a small object like Pluto have an atmosphere? It's actually not dense. That's a good answer. But it's actually not dense. The density of Pluto turns out to be about 2 grams per centimeter cubed. That's about midway between the uncompressed density of a terrestrial planet, 3.3, and the density of a Jovian planet, somewhere around 1. So it's somewhere between the Jovian density and the terrestrial density, which is why scientists have concluded that it's roughly half ice, half rock, because its density is somewhere halfway between as well. Okay, so it's actually not the density. That was a very good call. So it's not very massive, not very big. How could it have an atmosphere? Well, that would go with what Alon said. It doesn't. Why doesn't Mercury hold on to the atmosphere?
Is it because of the sun being so close?
The sun is so close to Mercury that the speeds of gas molecules would be going really fast. So Mercury can't hold on to them. Out here, what's the temperature going to be like? Yeah, very, very cold. So the speed of molecules is going to be very slow. So even though it doesn't have a lot of gravitational pull, it can still hold on to the atmosphere because it's just not moving very much.
The atmosphere also be a little bit denser too, so it doesn't like float off. Wait, no, there's not a big.
That's the same thing.
That's the same thing, yeah.
Okay, so it has some atmosphere, which is cool. And it has mountains with heights up to 3,500 meters. That's a pretty good sized mountain. So it's not perfectly smooth. I've got a bunch of pictures here. You might have seen these pictures. This is a enhanced color, I believe. This here, some people have likened to a heart. Other people said it looks like Snoopy. It depends on how you view it, what you see. But it's very interesting. Nobody expected what they saw when they actually got there. This is the last major thing in the solar system that had gone unexplored. And so it's pretty exciting to have these pictures and see, yeah, we've got impact craters and we have different kinds of topography, very reflective here, has some red color here.
Is that an actual picture of it?
Yes, that's an actual picture. Like I said, I think it's enhanced color. Yeah, it says right here. Colors you see have been somewhat enhanced to bring out subtle differences. But that's an actual picture, an actual photograph. And looking closer at the surface, what would you say about this surface here? Looks young, right? You have signs that something was flowing and froze. What about the stuff on the other side? Looks like what? Looks like mountainous. Mountainous region. And then you have over here what looks like an older surface. The mountains in that look older compared to the younger side. But you don't see lots of craters, so they're not that young or that old, right? Because you don't see signs of craters. Now looking at Charon. Once again, enhanced color on the left, non-enhanced color on the right. Looking at Charon, it has a funny polar ice cap. Yes, even out there where it's super cold, you still have a colder region. And so you have different situations. This here is very interesting to me. That's Well, I would suggest that would be signs of a major impact at some point. Rings. All of the Jovian planets have rings. If the question is which ones have rings, it would be all of the Jovians. And you can see here where the rings lie. And so for Jupiter, it actually has a continuous ring that goes out for a bit. Saturn, it has a much bigger continuous ring. Uranus has a bunch of discrete rings. Neptune, 2 discretes, and then a thicker one. Notice there is marked the boundary for stability. All of the rings are inside of that. And you do have some moons. The moons are marked that are inside of that stability, moons inside the rings. And those moons cause things like in Saturn's rings, you have regions where it's very, very thin. And that's because the moons have cleared the stuff out. The moon comes by, and it comes by at a different period than the stuff around it, and it causes stuff to come diving in or diving out, hits other stuff, comes into equilibrium at a different radius. Called shepherd moons. So here you can see a cleared out region because of a separate shepherd moon. You have other moons that are cleared because of resonances like remember we talked about with the Galilean moons having the 1 to 2 resonance between the moons? Well, that kind of resonance will clear out a region in a ring as well. Because you'll have every other time it comes around, it gets pulled out, and so it sets up a going in and out pattern, and then that stuff that has the pattern going in and out collides with stuff, ends up in a different orbit. And so there are 2 ways that we have these gaps. One is from shepherd moons, moons that are in the region, keeping stuff from there, and then resonance from moons. I don't have any pictures of it today, but I think it's Uranus has what looks like a braided ring. Rings that are going around each other like this, which is another resonance issue. This is what an artist's rendering of the Saturn rings looks like. Ice balls. From the video we saw in class, last class period, some are as big as houses, some are tiny like grains of sand. Depends on where you are in the rings, what size they are. But it's not a solid ring. It's a bunch of, if you want to, you could count this as hundreds of thousands of moons. Each one of those little babies is a moon. Nobody calls it that way, but that's what it is. It's ice balls and some dirt stuff orbiting around Saturn. This is just looking at Uranus's rings. Jupiter, Uranus, and Neptune, all of those, because their rings are made of tiny particles, they're best viewed in backscatter. Like if you have sunlight hitting it and looking at reflecting back, that's, I think, the best way for viewing. Or no, forward. Okay, I've got it backward. Forward. If the light's going through the ring to you, then you see it blocked. That's the best view. That's forward scatter. Picture of the rings around Neptune. Just getting some pictures of the rings so you can see, they've been observed. It's not just, somebody's fancy idea. And illustrating the shepherd moons, I've already talked about enough. Let's talk about comets. And when we talk about comets, first thing to know, there are not alien spacecraft hiding in the comet tails. You guys look at me funny, but there was a cult called the Heaven's Gate cult that believed that when this comet Hale-Bopp came by, that hiding in the tail of Hale-Bopp was an alien spacecraft that had come to take them. And the only way that they could be transported to the alien spacecraft was if they killed themselves. And so they ate some poisoned yogurt, put bags over their heads, if I remember right, and waited to be transported to the spacecraft hiding in the tail of the comet. Don't do that. these people weren't idiots. They were smart people. They made their money by doing, by providing websites, doing the programming, setting up websites. I think they were reasonably sophisticated people. One of them, by the way, was the actress, was it Michelle Roberts or something, the one who played Uhura? Her brother was one of the people in that. But they were misled by a charismatic leader who convinced them, among other things, that being a man wasn't good. So the men would go through the process to become eunuchs. I'm not sure why again, but people will do strange things in the name of religion. So what is a comet? That's our goal here, really. It's not to understand Heaven's Gate. So a comet, first of all, you have two tails here. This tail here, this tail here. One of them is an ion tail. One of them is a dust tail. The ion tail, that is ionized particles that are being blown away by strong interaction with the sun's solar wind. So the ion tail is blowing directly away from the sun. The other one, the dust tail, is still being affected by the pressure of the solar wind. So it's still generally being pushed away from the sun, but it's also going to be trailing behind where it's been. So that's why the two separate. One is directly away from the sun. The other one is being pushed that way, but also trailing. I don't remember why. I was going to reorder these. I kept the slides in the order that they were in the textbook. I don't remember why it went back and forth with the comet and the asteroids. These are where we have asteroids in our solar system. And you see we have the asteroid belt between Mars and Jupiter. Not all asteroids are in the asteroid belt. You'll see plenty of asteroids in here, closer. This picture is a little disconcerting, right? There's a couple asteroids right there beside Earth. There's a big group here that's called Trojans, a big group here that's called Greeks. I had never seen the separation between Greeks and Trojans. I always called both of them Trojans. But those are asteroids that have set up an orbit with Jupiter. So they're all orbiting together with Jupiter. They're being held in place by Jupiter's gravitation. Yes, Alan.
But shouldn't Jupiter clear out its orbit?
If you add up the mass of all of those Greeks and Trojans, it's minuscule compared to Jupiter. So that's a very good observation. And the answer is, the calculation is based on the mass of stuff that's left behind, and the mass of that stuff that's left behind is minuscule compared to Jupiter's mass. But, I mean, that's very good critical thinking. Appreciate that. Anybody have any idea what the biggest asteroid is? Ceres. So, I don't have a picture of Ceres next. I thought I did. I thought I had Ceres and Vespa on the next slide. The asteroids come in three types: S, C, and M. Oops, I was close. S, C, and M. I guess I can't be a weatherman yet. The S and C types are believed to be primordial material. That is, stuff that was here when the solar system formed that clumped together and hasn't been significantly changed. But S and C are different. The C stands for carbonaceous, which means that it has carbon-containing organic, if you will, compounds. Whereas the S are stonier silicaceous. Silicaceous. That means made of silicates, like rock. The carbonaceous ones are the same as the stony ones, except that they have, in addition, the carbon-based molecules. So there must have been, the belief is those are both primordial, both the stuff that was originally here, but there's a different composition because they apparently were formed in different locations. Then you have the third one. Both of those, especially the C-type have very low reflectivity. The S-type are more reflective. And then you have the M-type, metals. Those ones are metallic. It says differentiated. Differentiated means that they've been heated, more dense stuff is settled to the bottom, and these are the more dense metal. So these metallic asteroids are going to be much brighter because the metal is very reflective. So 3 different types of asteroids, which suggest that you have some pristine material and some stuff that maybe had started going through planet formation, and differentiation being one of those steps in planet formation. What are the 4 steps in planet formation? The first is differentiation. We have flooding, cratering, slow surface evolution. So those metallic are believed to be something that started the planet process. It had the differentiation, enough energy from stuff coming together that it heated, essentially was molten, the more dense stuff sunk to the center. And then it subsequently was broken apart for some reason. Probably a collision. Some people have posited maybe it was just gravitational interaction with Jupiter was enough to shred it. Here is an example of a meteorite that has been identified as coming from the asteroid Vesta. Once again, how do they know it came from Vesta? It says positively identified. It doesn't say positively. Identifies volcanic fragment from the crest of asteroid Vesta. Oh, it's Vesta, not Vesta. Vesta is a moped. How do they know? Okay, educated guess is Clayton's answer. They do it by elemental analysis. What percentage of different isotopes of the different elements does it have? And then they look around and they believe. It seems to me far-fetched that they could identify this, oh, it came from Vesta. But they're convinced and they know more than me on this, that's for sure. When you look at that, what does it look like? Reptile skin. What does it look like to everyone else? Yeah, it looks like just a big piece of metal to me. Magnet rock, piece of metal. And in fact, that's really what it is a big piece of metal. And so it is magnetic, by the way. I mean, magnetic. You bring a magnet, it'll stick. Because it's largely iron-based. Questions?
So I have a friend who studied meteorology, and I was just wondering, like, what specific, I know, like, obviously meteors, but, like, what specifically about meteors do meteorologists?
Wait.
Meteorologists don't say meteors.
Oh, okay, just kidding. See, I'm totally wrong. See, I need to be educated here. There you go. Oh, weather. Wow, I just love that.
Okay, but let's talk about the words. That's a good segue into the words.
There you go.
A meteor, I'm not going to ask you what is a meteor, I'm just going to tell you what a meteor is. A meteor is light in the sky. Meteors are caused by an object that comes from outside the Earth's atmosphere that comes into the Earth's atmosphere. That object is called a meteoroid. So a meteoroid comes into the Earth's atmosphere, you see light, the light is the meteor. And if something hits the Earth's surface, that's a meteorite. So you have meteoroids, meteors, and meteorites. And then there's, I think I already mentioned this in class, but it's like a month or so ago. Almost all meteors are caused by little objects that are the size of a grain of sand. All, not just almost, all meteorites are the remnants of an asteroid. Not a little grain of sand. How can those two both be true? It's kind of like our computer science class. You have a riddle. And it is true, this is real fact. It's not some funny made-up thing. Well, they're Siamese twins living in Great Britain. No, Siamese twins who are going to move from Alabama to Great Britain. That's what the joke was. Anyone? Well, let me lead you down the path then. If I have a a meteor that's caused by a little grain of sand-sized meteoroid, what's going to happen to that little grain of sand-sized meteoroid as it passes through the Earth's atmosphere? It's going to burn up. So what kind of meteorite do you have if it burns up? None. Because the meteorite is what hits the Earth. And so almost all meteors are grain of size, little piece of dust, grain of sand size. But anything that hits the Earth had to be much bigger than that. Came from an asteroid. Now, meteor shower. I don't have meteor showers at all in today's lecture, so everything here is just coming from my head, not from slides. Meteor showers. You guys have probably seen meteor showers. First, my mom was so disappointed when I told her there's going to be one of the most historic meteor showers. There's going to be tons and tons of meteors. She goes out and she's like, I only saw like 1 or 2 every minute. That was no great shower. For meteor showers, that is a great shower. Meteor showers are measured in meters per hour. And, if you have like 400 meters per hour, that's a great meteor shower. Well, if you break that down into minutes, that's not that many meteors per minute. My mom was expecting it to be like the little block prints you might have seen from the meteor shower that happened like November 13, 1842 or something like that.
44.
18 what?
44.
44? So, okay. The day that Seventh-day Adventist tradition states the day the stars fell. I know it's November 13th because that's my birthday. But that's not the year I was born, so that's why I get the year wrong.
Really good birthdays.
I know, it's hard to tell. So those woodblock prints make it look like you have hundreds of meteors all at once. Not so. So you should never go out for a meteor shower expecting to see the entire sky filled with meteors all at the same time. But when you have a meteor shower, if you were to examine the meteors for an hour, you would see that they all appear to be coming from one place, radiating from a place. And so when they name the meteor showers, they name them like the Orionids, meaning that they are originating in the constellation Orion. Now, of course, are they out there in Orion where the stars are? No, they're the Earth's atmosphere. So why would they all look like they're originating in Orion?
Because they're in the constellation.
Okay? They're in the area of sky that's in Orion because the Earth is hurtling toward Orion at that point in time. Right? The meteor shower occurs because you have a big cloud of dust and debris left behind by a comet. And as the Earth goes through this cloud of dust and debris, the dust and debris comes into the Earth's atmosphere, burns up, and makes streaks of light. They're going, from where we're headed to behind. Okay, enough on that. Back to asteroids. These are the first 3 pictures of asteroids. We have Matilda, Gaspara, and Ida. Or Gaspar, Gaspara, I always pronounce it wrong. You have Gaspara as an S-type, Matilda as a C-type. So they're different types. What do they look like to you? Rocks, right? They look like rocks. They're not really impressive. You do see that they have craters on them. What would have caused those craters? Not volcanoes. What?
Smaller asteroids.
Yes, smaller things that hit them. Oh, I'm out of time. Here is the picture that was taken last week by the Japanese lander. This is looking at Ryugu. Ryu is dragon, or Ryugu. Can't read either. I don't know what gu means. Anyone? Eli?
Where are you? Oh, not over. Okay.
Anyway, they landed here. They have a rover that's more of a hopper. Took this picture and then hopped. But you look at that surface and, I can't really tell what's going on there. But I can see that it's a rough surface. It's very interesting. Okay, I see people are ready to go. I am out of time, so I will let you do that. Have a happy Sabbath, everyone.